Hello everyone. Today we are going to solve question number 268, missing number from LeetCode. Okay. So we have previously discussed this question using three approaches, which were not so good. This time we are going to explore two new approaches to solve this question. These two approaches use mathematical function to solve this question. Okay. So let's see how this mathematical function are utilized. First approach is some formula approach. So let me revise you this question first. This question is like we have an array. Okay, we have this array, and it will be having one value is missing. Why we have one value is missing is uh, since we have an array of size 6. Okay, and we have to store numbers ranging from 0 to n. Okay, so since 0 and n both are included over here, so the total number of integers inside our array should be 7. But since we have 6 spaces, that guarantees that we'll be having a missing integer over here. Okay, so this time we are going to use some formula approach. Okay, this formula approach uses time complexity of O of n and space complexity of O of 1. Okay, so to solve this question, what we're going to do is we're going to have a sum, unexpected sum that will be the net sum if these integers contain if this array contain all the integers. Okay, so like the expected sum formula is over here, n plus n into n plus 1 divided by 2, which I guess we all have studied in class 8, 9, 10. Okay, so we can use this formula to solve to get an expected sum, right? We can get an expected sum, and then what we have to do is we have to iterate over this array, right? We have to iterate over this array, and then we can get an actual sum. Sorry, an actual sum. We can get an actual sum what the integers are actually stored over here. So once we have a value that tells what the actual arrays are stored and what the total should be, we can subtract both of them to get a final answer. Okay, so let's see this example I've built over here. uh, I have copied the same example from this above array. Okay, so the size of the array was 6 and the n value over here is 6. So 6 into 6 plus 1 divided by 2, which gives 21. Okay, so the expected sum was 21. The next thing what we have done is we have summed the elements inside the array, right? 2 plus 1 plus 6 plus 0, right? We have summed these to get 17, right? So we got 21, we got 17, we subtracted both of them to get a final answer, and as you can see in this array, we have 4 as our missing number, right? So let's try to code this one, and then we'll see the second approach, right? So int n is equal to nums dot size as a utility, and then we have long expected is equal to n star n plus 1 divided by 2. This is a expected sum for the size of the array, right? And then we'll be having okay, I forgot to mention you a point that we can use long to avoid overflow over here, because n into n plus 1 might give us a number bigger than integer, right? So we can use long over here. Okay, so long current sum, okay, current sum is equal to 0. For now we have kept it 0. Now we have to iterate over this array, right? Int nums okay, int num given nums current sum plus equals to num, right? So this way we have sum all the integers inside from the array inside this current sum, right? Now we need just the subtraction of them, so we can directly return expected minus current sum. Okay, we can do directly this, and think it should be fine. Yeah, all cases accepted. Let's submit this one. So this question uses O of n time complexity. Okay, O of n time complexity and O of one space. As you can see, we have only constructed these two extra integers over here, long integers over here, and we have just iterated over this uh, vector, right? This is one way to solve the question. Now let's see one of the best ways to solve this question, right? This was also a beautiful way to solve this question, but now next see the XOR way to solve this question. So oh, we already know the question. Now what we are going to do is we are going to use property of XOR operation. What does the property say is, if you XOR the same value, the result will be 0, and if you XOR the value with any value with 0, the value remains same, right? So the XOR logic is written over here: 0 XOR 0 gives 0, 0 XOR 1 gives 1, 1 XOR 0 gives 1, and 1 XOR 1 gives 0. Okay, so what we are going to do is we're going to take a variable, a common variable. Okay, first what we are going to do is we are going to iterate over this array. Okay, first we are going to iterate over this array and XOR all these values, this, all of these values. Okay, next time what we're going to do is we're going to iterate over the indices, not the this actual integers. We are going to iterate over indices ranging from 0 to n. Okay, where n is inclusive, n is not excluded. Okay, so let me show you an example how it actually works. So let's take, we have taken this XOR variable as 0. So rather than doing every XOR, I have just collectively written the result. Okay, so through first iteration, okay, through nums, when we iterated once, we'll be having this result: 2 XOR 1, XOR 0, XOR 6, XOR 3, XOR 5. Okay, something like this. Obviously 0 would be a problem over here. Now for the second iteration, what we're going to do is we're going to iterate with these indices, okay, from 0 to n. So you can see the XOR of this was part till the first result. Okay, this was part till first result, and then we have indices over here, all the indices over here. The XOR property, to use XOR property simply, we can use now property 1 as XOR of A, and A gives 0. So obviously 0 are there, 1 will be crossed by 1, 2 will be crossed by 2, 3 will be crossed by 3, 4 will be crossed, 4 won't be crossed obviously because we don't have second 4, 5 will be crossed by 5, and 6 will be crossed by 6, and the only number that will be left will be 4, which will be a final answer. Okay, so this was our XOR approach to solve this question. So let me just code this one for you, and then we can just end this question, because yeah, we have discussed at least 5 approaches for this one, right? So this one will be XOR approach. So what we're going to do over here is we'll be having a XOR variable. So let me write XOR variable, right, which will be 0. Now what we are going to do is we are going to iterate first over nums, or you can do both ways, it doesn't really matter. Int num given nums, we have to XOR them. So XOR variable XOR equals num, right? So by this we have done the first part. This second step we have done till this. Okay, now we have to iterate again, but only on indices. For int I equals 0, I less than, okay, we haven't defined n, but we can directly use I is less than equal to nums dot size I plus plus XOR variable XOR equals to I. Okay, so this is the second part. This is the third step over here. Yeah, that we did. So after both, we will be having a final answer stored in the XOR variable that we created. Okay, so we can just return the answer as XOR variable. Okay, so let's run this approach. Yeah, that was from previous approach. Okay, so yeah, we have passed all the test cases. Let's submit this one. And yeah, we have like completed this one. We have good time space, although this one doesn't matter. Okay, so we have solved this question with almost 5 approaches. So this was good, a good question, right? So thank you for watching. I'll see you in the next one.